Hello students, my name is Professor Muhammad Asim and we are doing AdMath. AdMath for IGCSE students which have syllabus code 0606 and for CIE O level students which have syllabus code 4037. So both kind of students can get equal benefit from this course. Students, in last lecture we did question number 2 from past papers October-November 2015 paper 1-2. We are doing nowadays past papers of integration from different years. In last lecture we did question number 2. The topic is integration. Today we are going to do same paper question number 9, which is also belongs to the topic integration. But before I start this question number 9, I would suggest all those students who are new on my YouTube channel, kindly go to my playlist. There is a folder, name is AdMath. Watch lectures of chapter number 15. I have already uploaded. After watching lectures from chapter number 15 integration, you will have good command on this topic. Let's start question number 9, part number 1. You are not allowed to use a calculator in this question. Find integration of root 4 plus x dx. We know that if the function which have derivative is 1, root means 1 upon 2. The formula is if we have x power n dx is equals to 1 upon n plus 1 x to the power n plus 1 plus c. So the derivative of x, you know, 1, so we can apply this formula because the derivative of 4 plus x is also 1. So according to this formula, integration is 1 upon n plus 1, and here n is 1 upon 2 plus 1. Here x is 4 plus x power n plus 1 means 1 upon 2 plus 1. Simplify it. 1 upon 2 plus 1 is 3 upon 2. 4 plus x power 3 upon 2. 1 upon 3 upon 2 is 2 upon 3. 4 plus x power 3 upon 2. And don't forget to put constant c in your last step, because these are indefinite integrals. Indefinite integral means integration without the limit. So this is the answer of part number 1. 2 upon 3, 4 plus x power 3 upon 2 plus c. Now move to second part. Second part, first copy, then paste in my board, enlarge it so that you can see easily the whole question. Here we go. The diagram shows the graph of y is equals to root 4 plus x, which meets the y-axis at the point A, and the line x is equals to 5 at the point B. Using your answer to part 1, find the area of the region enclosed by the curve and the straight line AB. Students, we have to find the area between the curve and straight line. So we have two methods to find the area, but in both the methods one step is common, that is to find the coordinates of the point A and the coordinates of point B. How it is possible is very easy. Given equation of curve is root 4 plus x. You can see point A lies on y-axis, therefore the value of x is 0. So 4 plus x means 4 plus 0. Root 4 is 2. Hence the coordinates of A are x is 0, y is 2. Now for coordinates of B, the value of x is 5 and the value of y is unknown. So let the coordinate of B is x is 5, y is y. Again put 5y in the given equation of curve. Y is equals to 4 plus x, x is 5. 4 plus 5 is 9, 9 root is 3. Hence the coordinates of B is 3 comma 5 comma 3. We have to write x first. So x is 0 comma 2 and y is 5 comma 3. So this is the common step between both the method. Now first method is to find the equation. I am writing over here method number 1. For this regard we have to find the equation of a straight line AB. So we have coordinates of A are 0 comma 2, coordinates of B are 5 comma 3. First find the gradient. What is the formula of gradient? y2 minus y1 upon x2 minus x1. 3 minus 2 is 1, 5 minus 0 is 5. Then the equation of a straight line is y minus y1. You can take any point A or B. I am taking A. Y minus y1 is equals to m times x minus x1. So y minus 2 is equals to 1 upon 5x, or y is equals to 1 upon 5x plus 2. This is the equation. What this method says? This method says that integrate the entire straight line and curve with the help of a given limit. What I mean, first I have to write, then I will show. Integrate 0 to 5, 4 plus x root minus equation of a straight line 1 upon 5x plus 2 whole dx. This is method 1. Why I write equation of curve first? Because you can see in the question above is the curve and below is the straight line. And why I put it the limit from 0 to 5? You can see starting point is 0 and end point is 5. So this method is so easy. Now square root of 4 plus x. We have already integrated square root of 4 plus x root x in previous part. What was the answer? The answer is 2 upon 3 4 plus x power 3 upon 2. Now integrate 1 upon 5 x. Integrate 1 upon 5. X integration is x square upon 2. Minus plus minus 2. And integrate of dx is x. Limit is 0 to 5. Now apply the limit. 2 upon 3 4 plus x. What is x? X is 5 power 3 upon 2 minus 1 upon 5, 2 is 10, x square, that is 5 square, minus 2 into x, x is 5. So this is upper limit. What is the rule to apply the limit? Upper limit minus lower limit. Minus 2 upon 3 4 plus x. This time x is 0 and the power is same, 3 upon 2. minus 1 upon 5 2s are 10 x square, that is 0 square, minus 2 into x, x is 0. Simplify it carefully. 2 upon 3, 4 plus 5 is 9, 3 upon 2, negative 1 upon 10, 5 square is 25, 2 5s are 10, minus lower limit 2 upon 3, 4 plus 0 is 4, 3 upon 2, minus 1 upon 1 upon 10 into 0 square is 0, minus 2 into 0 is 0, 2 upon 3, 9 power 3 upon 2, 9 power 3 upon 2 is 3 square is 9, square square cancel, so 3 power 3 is 27, negative 10 25, 5 5s are 25, 5 2s are 10, 5 upon 2, negative 10, minus 2 upon 3, 4 power 3 upon 2, 4 power 3 upon 2 is 8, and 0 minus 0 is vanish. 3 9s are 27, 9 2s are 18, 2 10s are 20, minus 5 is 25 upon 2, 8 2s are 16, 16 upon 3, 18 2s are 36, 36 minus 25 is 11 upon 2. LCM is 6, 2 3s are 6, 11 3s are 33, 3 2s are 6, 16 2s are 32, 33 minus 32 is 1, 1 upon 6. So this is the answer of the required question. This is the first method. There is another method. We will call it second method. For second method, it is also very easy. See carefully. First find the area under the curve. Area under the curve means, I am writing over here, area under the curve. So integrate 0 to 5, 4 plus x root dx. We have already integrate in part number 1, 2 upon 3, 4 plus x power 3 upon 2, and the limit is 0 to 5. This is the area under the curve. So 2 upon 3, apply the limit, 4 plus x is 5, 3 upon 2, minus lower limit 2 upon 3, 4 plus 0, power 3 upon 2. Simplify it. 2 upon 3, 4 plus 5 is 9, 3 upon 2, negative 2 upon 3, 4 plus 0 is 4, 3 upon 2, 2 upon 3, 9 power 3 upon 2, you know, we just did it, that is 27, 2 upon 3, 4 power 3 upon 2 is 8, 3 9s are 27, 9 2s are 18, minus 16 upon 3. So the answer is 18 3s are 54, negative 16, 38 upon 3. So this 38 upon 3 is the area under the curve, means the area of this whole thing. This 38 upon 3 mention is the area of this whole thing. But we just find the area between the straight line and the curve. So we must find the area of this trapezium OAB, or we can say OC if I assign the name C. OABC. Find the area of trapezium. Area of trapezium OABC. The formula of the area of trapezium is half sum of parallel sides, that is 2 plus 3 multiplied by height. Height is 5. You can see what is 2, what is 3. See this. This OA is 2, you can see. This BC is 3, you can see. And this OC, which is height, you can see 5. So very easy. One upon 2. 2 plus 3 is 5. 5 5s are 25. 25 upon 2. Hence, the area required area is area under the curve 38 upon 3 minus area under the area of the area of the trapezium 25 upon 2. Take the LCM. 6 3 2s are 6, 38 2s are 38 2s are 76. Negative 2 3 is 6, 25 3 is 75, 1 upon 6. You can see the answer is same. So if we use any method and we get the same answer, it means the method is correct. Now choice is yours, whether you apply method number 1 or you can apply the method number 2. You will get the same answer. Sorry, you will get the full marks. For me, if I have given two choice, method number 1 and method number 2, definitely I will apply method number 2, because in method number 1 there is little more work, that is to find the equation of a straight line. So student, this is our today's class, where we did question number 9 from past papers October November 2015 paper 1-2. Definitely there is no more question of integration in this paper, therefore we will do other paper like paper 2 of 2015. Okay student, so this is our today's class. Hope you enjoyed and you have this class is definitely help to all those students who are doing past papers nowadays. My request to you, for all of you, kindly do subscribe my channel, and whenever you subscribe,